Image classification and object detection are the most focused topics in the field of deep learning and computer vision. However, video classification is equally important and deserves more attention. Video classification and video understanding are used for action recognition or action detection, where a model can recognize what action is being performed in the video, or it can detect if any kind of action is happening. For example, a model can be trained to detect violent action. Action recognition has many practical applications in surveillance, healthcare monitoring, and many more. Today, we will look at SlowFast networks for video understanding, which is from Facebook AI Research. This model can be used for both action recognition and action detection. SlowFast networks achieves state-of-the-art accuracy in Kinetics 400, Kinetics 600, charades, and AVA datasets, which are popular datasets for video understanding, action recognition, and action detection. The intuition behind this work is very simple. The authors observed that all parts in a video do not participate in motion. For example, when two people shake hands, the only part moves is their hands, and rest of the scenario remains relatively static. Again, when a person is running, this does not change the semantics of a person, meaning a person can be categorized as person when he is running or doing something else. Based on these intuitions, the authors developed slow-fast networks which has two pathways. First one is for capturing semantics of an object which is called slow pathway, and other one is for capturing motion called fast pathway. Both pathways use 3D ResNet and performs 3D convolution operation. 3D convolution is an extension of regular 2D convolution where convolution operation is performed over an extra temporal dimension along with channel and spatial dimensions. This temporal dimension is represented by the number of frames. In slow pathway, the authors used a temporal stride of 16, meaning they select one out of 16 frames and continue until the end of clip. Following this approach, for a 30 fps video, roughly 2 frames per second are processed by the slow pathway. In the fast pathway, the selected value for temporal stride is 2, so it selects 15 frames per second from a 30 fps video clip. As fast pathway works on large number of frames, to keep it lightweight and efficient, the channel size is kept lower than the slow pathway. The channel size of fast pathway is kept exactly 1/8 of the channel size of slow pathway. There are lateral connections from fast pathway to slow pathway so that motion information can be combined with the semantic information, which ultimately improve the model's performance. At the end of each pathway, the authors used global average pooling layer which concatenates the result from both pathways and reduces dimensionality. Finally, a fully connected layer with softmax function classify the action being performed in the input clip. As I told earlier, the model is tested on Kinetics 400, Kinetics 600 and charades action classification datasets. Kinetics 400 include short 10 seconds clip from YouTube with 400 categories of human actions. Kinetics 600 is an extension of Kinetics 400 datasets containing 600 categories of human action, whereas AVA dataset is used for action detection, which is taken from 437 movies where every person is annotated with a bounding box. In Kinetics 400, SlowFast networks scored 79.8% in top 1, which is 5.9% better than previous state-of-the-art score. Its top 5 accuracy is 93.9%. In Kinetics 600, the network achieved 81.8% top 1 accuracy and 95.1% top 5 accuracy. And it also achieved state-of-the-art accuracy of 45.2 mean average precision, which is a huge increment of 5.5 mean average precision from previous models. For AVA dataset, they used a version of faster RCNN object detection model to detect person and region of interest. After that, they used SlowFast networks to detect action. For this task, they actually retained SlowFast on Kinetics 400 dataset. After all this, SlowFast networks achieved 26.3 mean average precision, and when retained on Kinetics 600 and with non-local network, it scored 28.2 mean average precision. These results are from AVA version 2.1. On AVA version 2.2, it achieved 30.7 mean average precision when retained with Kinetics 600. SlowFast takes a fresh and intriguing approach to video understanding, focusing on the real-world situations and biological mechanisms for inspiration. Although it is not perfect for action recognition or action detection, it provides a milestone and a baseline for future research. If you liked this content, please like this video and share with your friends. To learn more about advancement of AI technologies, please subscribe to the channel. Thank you for watching.